All right, so determine whether the relation is a function, first of all. Okay, so let's remind ourselves real quick, what's it mean to be a function? How do we know when a relation is a function? And I'll throw this out there. Somebody raise their hand. You can either do it, you can raise your real hand or you can hit the little raise hand button. I don't care. Help me out here, somebody. What's our definition of a function? A relation is a function if each input blank has exactly one output. There you go. If each input has exactly one output, then it's a function. Okay. All right. So then is this a function or not? What do you think? Akira, is this a function? This relation that they give us up here, this set of ordered pairs? It is not a function. You're right. Because we can see that there are, for example, when we input a 5, we get two different outputs, right? So it's not a function. Akira, what's the domain of this relation?
5, 9.
5 and 9. Good, because the domain is the set of input values or x values, right? And what's the range?
1, 8.
1, 8. Excellent. Okay. Questions on that? Does that make sense? Okay. Good, good. How about this one? Now I'm giving you a graph. I want to know if, first of all, is this relation a function? So we're looking at the dark blue vertical line. Alara, is that a function?
No.
It's not. You're right. It's not, because it fails the vertical line test, doesn't it? If I drag a line across that graph, it intersects it in more than one place. In fact, an infinite number of places. You're exactly right. It's not a function. What's the domain of this one? What's the domain of this? What are all the x values that are graphed in that blue line?
X equals 5.
That's it. There's only one, isn't there? So it's not an interval this time. It's just a set of one value. It's just 5. So that's how we would write our, oh, come on now. There we go. That's how we would write our, oh my goodness. Struggling here today. Just do that. There we go. So it's only a 5, isn't it? Okay, that's it. What about, let's move on here. Tony, what about the range? What's the range of that graph? Good. So written in interval notation, it's going to look like this, isn't it? Because this is not just one value or a finite number. It's an infinite number of values. It goes all the way from negative infinity up to positive infinity, the set of y values that are graphed, right? And so that's what we'd expect on that one. Okay. All right. How about this? Another one. Determine whether this relation is a function or not. So what do you think, Aurelia? Is that blue graph a function? No, it clearly violates the vertical line test. So it's not a function. What is the domain?
The domain is x values, right?
Correct, yes.
-2 and 2.
Good. So it's all the values from -2 to 2. Now, am I going to include, do I have brackets or parentheses with those?
Parentheses?
That's going to be brackets. How come?
Because they don't go past that point.
But they do include those points, don't they?
Oh, yeah.
You see what I'm saying? So because we're including the values x equals -2 and x equals +2, we need to include brackets with this one, okay? So Brogan, what about the range then, the set of y values?
I don't know.
So
would it be 2 or no?
Okay, so the set of x values, the x values went from an x value of -2 was the furthest left that we could go on this blue graph, correct? Positive 2 was the furthest to the right, and all the values in between. An ant could stand on any of those x values from -2 to 2. What about the y values?
Wouldn't it be 3 and then -3?
Right. Okay. And if we write that in interval notation, it's going to look like this, isn't it? It's going to go from -3 to 3 in brackets because we are including an ant could stand on a y value and actually be at -3, or he could actually stand on a y value of +3, or any y value in between, correct?
Yeah.
Okay. All right. So how are we doing? How about on those last couple, 1 to 5? Okay. All right. All right. Type it in chat if you're not showing me fingers. Okay. All right. Next. So evaluating functions. Remember, evaluating function just means we're plugging a value in, right? Plugging something into the function, usually a number, but not always. So what about part A here, f of -7? They're giving us, here's where they define our function up here, isn't it? If we look, here's our function f of r. Okay, so if we're plugging in a -7, how do we go about doing that, Emily? How am I?
Plug the -7 into the R.
There you go. Good. So every place up here in my function where I have an R, I'm just going to open up an empty set of parentheses, right? And that's where I'm going to be plugging in that -7. So I'm going to have an empty set of parentheses +7, and then outside of the radical, I've got a +4. So that's going to be a -7. Now, what happens when I simplify that, Emily? What is the square root of -7 plus 7? What's -7 plus 7? Yeah, good. It cancels. Good. So I get the square root of 0, which is just 0, plus 4. So I get 4. Good. Okay, so there's the first one. And then I do the same thing for part B, wouldn't I? F of 29, I'm doing the very same thing. Every place I'm going to plug in a value, I'm just going to open up an empty set of parentheses. And the value I'm plugging in part B is a 29. So I end up with the square root of 29 plus 7. Well, that's 36. Square root of 36 plus 4. Square root of 36 is 6. Plus 4 is 10. Okay, no biggie. Okay, part C is a little tougher. Part C is just a little bit tougher. Gabe, talk me through part C, f of the quantity x minus 7. Now, I don't mean to, it's not that much harder, but it's got a variable in it. So it's going to look a little different. Our answer is, at least. So what do I do? Plug it in. Exactly. I'm still just plugging it in. The only difference here is just being that when I plug it in, I'm not just getting a number. I'm going to end up maybe with some x's in my answer, right? So f of something equals the square root of every place I have an r, I open up an empty quantity to dump something in. And the something that I'm dumping in is an x minus 7. Okay, so if we do the math this time, look what happens. I end up with the square root of x minus 7 plus 7. What's that equal, Gabe? What's x minus 7 plus 7? Yeah, the 7s cancel. And so I just get the square root of x plus 4. And I can't do anything more than that, can I? So that's my answer. The square root of x plus 4. When I evaluate my function f at x minus 7, that's what I end up getting. Okay, it's a little strange because I get x's in my answer, but once again, we expect that because we're plugging x's into our function, right? Okay, give me 1 to 5. Type it in quickly. If you're not showing me fingers, show me in the chat. Okay, I got to hear from everybody. I guess I did. Okay. Next one. Just a different representation of a relation this time. Okay, there's my relation f. Well, is it a function, first of all? They didn't ask us that, but you tell me. Is it a function, Jade? Does this mapping represent a function? It does, good, because each input only has one output. Very good. So while you're at it, Jade, what is f of 6? What's the output if I input a 6? 6, correct. That's it. Good. Okay, and we see that because of this arrow right here, huh? That's the arrow that 6 and maps it to the output value of 6. Good. All right, so now shifting gears just a little bit here. So an equation that defines y as a function of x is given. Okay, our equation has y's and x's in it. So we want to do two things. We want to, first of all, we want to rewrite the equation using function notation, right? So we want to write it in the form f of x equals some over here that's going to be an equation involving x's, right? So how do we do that? Well, remember that, first of all, we'll go back to something you've heard a whole bunch in your math classes. F of x is just a fancy name for y, right? They're interchangeable, x and y, okay? So to get to the answer that where it's f of x equals something, that's just equivalent to solving for y, getting the y by itself, and then swapping out the y for an f of x, okay? So to get the y by itself, what's the one thing I have to do, James Thatcher?
You have to minus 3x squared.
There you go. And that gets the y by itself. And so then we'll change the y for an f of x. And on the other side, we just get 3 minus 2x minus 3x squared. Now, we can change the order if we want to, but at this point, you don't have to. You could leave it either way. They chose in their answer to put the x squared term first, and then the x term, and then the constant. And there's might be a good reason to do that later on in the class when we start talking about polynomials. But for now, I don't care. Either way would have been fine, okay? And then finally, f of 3, well, that's just what I'm going to get when I plug 3 in, right? So if I plug 3 into this function, every place where I have an x, I'm going to open up an empty quantity. So I get negative 3 times something squared minus 2 times something plus 3. And my something this time is a positive 3. So what's that going to give me? I've got to use order of operations here, right? I've got to do exponents first. If I follow PEMDAS, there are no parentheses. I can't do anything in the parentheses, but I got to deal with this exponent first. 3 squared is 9. And then after I've done the exponents, I can do my multiplication and division. So 2 times 3 is 6. And then negative 3 times 9 is negative 27. Negative 27 minus 6 plus 3 just all adds up to negative 30. So that's my answer. Okay, so be prepared for something like that. Okay, what about this? Now we're back to the increasing, decreasing, constant stuff, right? So they gave us a graph of a function in this case, and they want us to define the open intervals where the function is increasing, decreasing, constant. Okay, so where is it increasing, first of all? James Weller, give me one set of x values. You don't have to be fancy with interval notation if you don't want to initially either. You can just use language, but I want to know, tell me one interval, describe one interval where the function is increasing. And remember, that just means an ant walking in the positive x direction. So from left to right would be walking uphill where the function is increasing.
Left to right, it increases from ordinate -1.
You're right. -1 to what? So between -1 and what?
Between -1 and 0.
There you go. So there's one, right? So for the first part, if we're going to do the increasing intervals, how about in red? So there's one part right there. It goes from -1 up to 0. Okay. What's another one? Jordan, what's another place where it's increasing?
From -1 and then 2.
From -1 to negative. Okay, but now look, it's decreasing there, isn't it? Because as we're walking from left to right, ants walking downhill.
Okay, so from -3 and -2.
Okay, and I don't have to stop at -3. I could go all the way from where to -2? There you go. Good, because that arrow indicates that this goes down and to the left forever. So that whole interval from -infinity to -2 would also work. So if I wanted to write those using interval notation, how would I write this one on the left here, Jordan?
-infinity, parenthesis -infinity, and then -2.
Okay, good. And then now if we read the instructions here, and you got to always be reading the instructions on these questions. It says, type your answer in interval notation, use a comma to separate answers as needed. So we're not using the union symbol on this one. We're just using a comma to separate the intervals. And Jordan, what about the second interval? How would I say that one?
Parenthesis -1 and then parenthesis 0.
There you go. Good. Okay, so there's the first part, right? What about the second part? Where is the function decreasing? So following that same logic, Kylie, can you tell me, we'll graph these in blue. Can you tell me an interval where the function's decreasing? Questions to Kylie? I think your mic's on, Jordan. Okay, how about Lindsay?
-2 to -1.
Okay, good. So there's one place, isn't it? Between -2 and -1. And how would I say that using interval notation?
Comma, -2. I mean, not comma, parentheses, -2, comma, -1.
Good. And then parentheses. Good. Okay. And then can you see another one?
From 1.
I have to stop at 1. What's that arrow mean?
Oh, then it goes down.
Right. Okay. So it's going to go down and to the right forever. So how would I say that one using interval notation?
Comma, 0. I mean, parentheses, 0, comma, and then the infinity sign.
There you go. And then parentheses. Good job. Good job. And is there going to be any place where the function is constant, where it's horizontal? No, you're right. Okay, good. All right, how about this? Now, write an equation of the line in standard form with integer coefficients. Okay, so let's take a second and let's quickly review all of the different forms we have for linear equations. We have three of them, right? Let's go through those, and you're going to need to know those. In fact, what I think I'm going to do, we did this fifth period, and a lot of people couldn't remember, which I get. I mean, we've been out of school here for a week, and some of this stuff goes back several weeks. So I understand why maybe it'd be easy to forget this stuff, but it's important to remember it. So I'm going to have a part on the test, which is nothing more. I mean, this couldn't be easier. There are going to be some questions on the test. They're going to be nothing more than just writing out the forms of the linear equations, all three of them. So I'll say write out slope-intercept form, right? And if I said write out slope-intercept form, what would you write? If I said write out slope-intercept form, let's see here. McKenna, what would you write?
Y equals mx plus b.
Good. There's the first one. What if I said standard form of a line? This is the one that you guys haven't probably used a ton, so I can see why this would be an easy one to forget. Do you remember it, McKenna?
Is it ax plus bx equals c?
Plus b
Y.
y equals c. Very good. Okay. And remember, for standard form, we had some rules too. For standard form, we said that a, b, c are integers. They can't be fractions, right? So that was one rule. We had another rule that the greatest common factor of A, B, and C is 1. And then the other one was that A is positive. Okay? Those were our three rules. And then finally, the last one we had was the most recent. So I bet you guys might even remember this one the best. Slope form. Now, slope-intercept form had to include a slope m and a y-intercept b. Point-slope form is going to be a little different. It has to include a slope and the coordinates of a point. So what's that one? Y, anybody remember? Y.
Isn't it y minus y1 equals m and then parenthesis x minus x1?
Good. Y minus y1 equals m times the quantity x minus x1. There you go. So there's all three of our different forms of linear equations, right? There they are. All right, so what about this one? It says write the equation in standard form. All right, so let's start off. I'm going to rewrite this equation a little bigger. Okay, well, first of all, let's go through. To be in standard form, it's in the form ax plus by equals c. So we have to have the x term on the left first, then the y term on the left equals the number, the constant. But before we do any of that stuff, whoops, that's supposed to be an equal sign, isn't it? What's wrong right away? What's wrong with that? Melinda, do you see anything wrong with that right away?
I'm not sure what's wrong with it.
So if it's in standard form, remember our rules. A, B, and C have to be integers. We can't have any fractions.
So would you need to cancel out that fraction on the x?
We would. And how do we clear fractions?
you multiply it by 3?
Yeah, good. We're going to multiply everything by 3. We'll distribute a 3 all the way through. So 3 times negative 4y is negative 12y. 3 times 5/3, that cancels the 3 on the bottom, right? And I just get, oops, I just get 5x. And 3 times negative 5 is negative 15. So there's our first step. And that was supposed to be negative, wasn't it, up there? Yeah. Okay, that's good. So we checked off part 1. We know we've got all integers. What about the form of this thing? Are the terms in the right places? Can you see something else we have to do here, Melinda, to get it into this form?
Do you need to put that negative 5x on the left-hand side?
I do. So I'm just going to add 5x to both sides, right? So it moves that 5x to the left. And then I'm going to put my x term first. So 5x minus 12y equals negative 15. So we just got to check and see if we meet the other criteria. Is the greatest common factor of A, B, and C 1? Is there any other number other than 1 that divides into 5, 12, and 15? No, we're good, right? And is A positive? Yeah, it is. It's positive. It's positive 5, isn't it? Now, if it were negative, I'd have to either multiply or divide everything by negative 1 to change all of the signs. But this time we made it. There it is, right? So there's the equation of our line in standard form. Give me a 1 to 5 on that. Okay, good. Good. So make sure you're typing in chat if you're not, if you didn't show me fingers. Okay, good. All right, so what about this then? Find the slope of the line passing through the pair of points, or state that the slope is undefined, and then indicate whether the line through the points rises, falls, is horizontal, or is vertical. Okay, so take a look at those. Let's start off by reminding ourselves, what's the slope formula? How am I going to calculate slope here? So, Olivia, do you remember the slope formula? M equals what minus what over what minus what? Questions for Olivia. Do you remember that slope formula? I'll get you started. M equals y2.
Y minus x2,
So y2 minus
y1,
y1. There you go. Divided by,
x2 minus x1.
there you go. Good. So rise over run. The change in the y values over the change in the x value. So what would I get here if I plug that stuff in for these 2 points? What minus what on the top?
-1 minus, or technically +1.
There you go. Good. Minus a negative makes it a +1. And on the bottom?
And then -6 + 2.
Okay. So if I do the math then, on the top, those cancel and I get 0. On the bottom, I get -4. Well, 0 divided by any number is what?
0.
0. Yeah. Okay. So the slope is 0. So what does that mean about the line? From left to right, what are we doing? Which one of those best describes the line then? Is it rising, vertical, falling, or horizontal?
Horizontal.
Horizontal. That's it. Good. So 0 slope corresponds to horizontal line. Very good. Okay, what about this? Graph the following equation in our Cartesian plane here. Y equals 2. So Owen, what's that going to look like? If I graph the line y equals 2, what am I going to get? Questions to Owen. Owen, you there? I guess not here. So, Savannah, bail him out here. What's that going to look like? Y equals 2. Okay, so now let's think about what we can about this. I'll give you some good hints. Y equals 2. If we get something like either x equals just a number or y equals just a number, remember, that's telling us what all of the y or x values for every point on the line have to be. In other words, the y coordinate is always going to be 2. The y coordinate is always going to be 2. Think what that would look like as a line. If I draw a line where every point on the line has a y coordinate of 2. Does that help? And look, here's the easiest one would just be this guy right here, wouldn't it? There's the point 0, 2, right? But every point on the line is going to have a y coordinate of 2. Does that jog your memory, Savannah? If it doesn't, that's fine. Okay. Chavino, help her out. Help Savannah out. What's that going to look like then?
It would be horizontal through 2.
There you go. Good. It's going to be a horizontal line through y equals 2, right? And the reason for that being that every point on that line has to have a y coordinate of 2, right? This one would be negative 6, 2. This one right here would be 4, 2, and that one would be 0, 2, but they're all 2. If the y coordinate's always going to be 2, then it's going to be a horizontal line with all y values equaling 2, okay? Okay, how about this? Rewrite the given equation in slope-intercept form and then graph the line. So we have 2x plus 7y minus 14 equals 0. Well, we got to put this into slope-intercept form. And we know what that is. We already reviewed that. We know slope-intercept form is just the form y equals mx plus b. So if I'm putting a line into slope-intercept form, all that really means is I'm isolating y and simplifying, right? So what would the steps be then to accomplish that? Owen, what are the steps going to be to put this into slope-intercept form, my original line? Okay, Akira, help Owen out. What do I got to do first?
Subtract 2x and add 14.
There you go. Good. So we're going to subtract 2x and we're going to add 14 to both sides. And we want to do that so we can get rid of the x's and the numbers on the left. And that helps a lot. Then we end up with, after that step, we've got our 7y on the left. And on the right, we've got negative 2x plus 14. Alara, what's next to get that y by itself?
Divide by 7.
Okay, good. Divide by 7. Now, you can divide by 7, or you take your pick. You can divide by 7. Dividing by 7 is the same thing as multiplying by 1/7. So you take your pick. Either way, though, when we divide by 7, we're just going to divide each term separately, right? So the 7s will cancel, and I end up with y equals, now what am I going to get from this first term? What's negative 2x divided by 7? What's that going to give us, Tony?
Would that just be negative 2 over 7?
Negative 2/7 times x, right? We want it to look like mx. So my slope is negative 2/7. And then plus 14 over 7. Well, that's just 2, isn't it? Right? So, Tony, if we graph this line then, so there we put it into slope-intercept form, right? Now let's graph this line. How do we go about graphing that line? We need 2 points and then connect and extend. Where do we start?
I'm sorry.
Y-intercept. So we'll start at 2. Good. We'll start at the point 2 on the y-axis. And then what am I going to do with my slope?
You go down to because
Good. So we're going to rise by -2, and we're going to run by how much? 7. Okay. And so making a slope triangle, remember the negative always goes with the top, right? Always goes with the rise. So we rise -2 and run 7. And then once I get my other point, now all I've got to do is just connect and extend, and there's my line. Okay. All right, let's maybe do one more today, and then that'll shorten things up for next time. Okay, so last one. Decide whether the pair of lines is parallel, perpendicular, or neither. This is a good place to stop. We'll finish this one up, and this will be, if we get through this, it'll be good. Okay, so Aurelia, how are we going to know, first of all? How are we going to know if the lines are parallel, perpendicular, or neither? What's going to tell us?
If they're parallel, then the slopes are going to be the same.
Good. So the slopes are equal if they're parallel. What about if they're perpendicular?
They're opposites, like one would be 5 and one would be 1/5.
Okay, that's reciprocals. You just told me, right? They're reciprocals, but there's 2 parts to it. They're reciprocals, and what else? So if one is 5, the other isn't 1/5, it's going to be negative. There you go. So they're negative reciprocals or opposite reciprocals. Good. And so all we have to do then is just figure out what's the slope of each of these 2 lines. Now, remember, there's a trick with this. To find what the slope is, we're just going to put these into slope-intercept form, but we don't really care about the y-intercept, do we? All we really care about is when I isolate the y, what's going to be the coefficient of x on the other side, right? So what would the steps be to get the y by itself here in this first one? Brogan, what am I going to do to get the y by itself in this first equation up here?
Subtract y.
I want to get the y by itself on the left side.
Oh, okay. So subtract x.
Subtract 5x. Good. So we're going to get 3y equals -5x plus, we don't even care, right? It's +7, but we don't even care because all we care about is what's going to be the number in front of the x. What's the next thing I do, Brogan, to get that y by itself?
You wouldn't divide by 3, would you?
You would divide by 3. Very good. So if we divide by 3, we're going to end up with y equals -5/3 x plus, who cares? There's our slope, right? There's the slope of the blue line. Okay. Emily, same thing for, we'll call this the red line. What do I have to do to get the y by itself?
You would subtract 3x and divide both sides by 5.
Okay, good. So we're going to get 5y equals -3x plus 10. Not that we care about the plus 10 part. And then we're going to divide by 5. Right? And that gives us y equals -3/5 x plus, who cares? And here's our other slope, -3/5. So then, Gabe, are these lines parallel, perpendicular, or neither? If -5/3 and the red slope is -3/5, you tell me. Okay, what's your thinking? It's neither. Good, good. Because they're reciprocals, but they're not opposites, right? They're both negative. One would have to be negative and one would have to be positive. You caught it. Good job. So the answer to this one would be neither. Okay? That's a good place to end for today, I think. All right, so looks like we're just got about a minute left. So I'm gonna let you guys sign off early and get up and stretch your legs a little bit before advisory. How's that sound? And then we'll see you on Wednesday. The review assignment will be up, so start on that.